Hello everyone, my name is Hao, and today I will present my paper Kanbun-LM reading and translating Classical-Chinese in Japanese methods by language models. You may have heard about Classical-Chinese, it's very famous and there are a lot of data in mainland China. Classical-Chinese was introduced to Japan about 2000 years ago. Although there are many common cultures between Chinese and Japanese, it's not very easy for Japanese people to read this because Chinese and Classical Chinese is in SVO order, but Japanese is in SOV, so it's very difficult for them to read Chinese. That's why Classical Chinese began to be adapted to a Japanese form, Japanese reading and translating methods in about 8th century AD. This form is called Kanbun-Kundoku. In this paper, we'll call it Kanbun. Kanbun has significantly impacted Japanese literature, such as Mang Youshu and the Tale of Genji. Here is a portrait example of a very famous portrait in China, Chun Xiao. And for normal Chinese people, we will just read the characters one by one from up to down. But Japanese people cannot do that, so we actually need to reverse the sentence. So, for example, here is a mark, we call it Latin, and we can use this mark to reorder the sentence, so we can let Japanese people read it too. But there is a very serious problem. There are many Classical Chinese data in China, but Kanbun resource really remain very scarce in Japan. For instance, there are over 50,000 town points are accessible via the internet, but only around 500 town points adapted to Kanbun are accessible, so it's really low resource. So in this paper, we want to build a high-performance Classical-Chinese-to-Kanbun translator so we can address this problem. At first, we built a dataset, and this is the first Classical-Chinese-to-Kanbun dataset in the world. This dataset contains the original Chinese text and the Japanese reading order, which is in SOV, and the Kanbun text. Then we use this dataset to do two tasks. First, character reordering. This is very simple. We want to make the sentence from SVO to SOV. For example, we have this sentence and we can reorder it into SOV like this. And there's another task called machine translation, which are sequence-to-sequence tasks that translate Classical Chinese text into Kanbun. So after reordering it, we also need to add some auxiliary words or some something like this, some suffix words, so we can make it into Japanese. And this is our implementation for the two tasks. Well, for details, please read our paper. We use BERT for character reordering and T5GPT for machine translation. For results, for the character reordering, all of our models outperform the baseline and the human performance. The best model is Roberta Classical Chinese, which was pre-trained on an ancient Chinese corpus, and there is also an interesting point that BERT is more accurate in details. So for the perfect match ratio, human's performance is actually similar to the Roberta Japanese, which is both around 0.6, but for Kendall's correlation, human is much weaker than Roberta Japanese. And for machine translation, MT5 large perform best in both automatic evaluation and human evaluation. And the reference, which is our data, obtained high scores, proving that our data is high quality. So for conclusion, we constructed the first Classical Chinese-to-Kanbun dataset in the world, and we conducted quantitative evaluations for character reordering and machine translation. We also achieved solid results in both tasks using language models. We also have released our code and dataset on GitHub, and we also made a small demo for translating Classical Chinese into Kanbun. If you are interested, please check it. Thank you.